Among the beauty of aspens, scientists from Northern Arizona University are working on an invention that looks like it belongs in an Iron Man movie.
We work on smart wearable technology, things like smart braces and powered exoskeletons to help people walk.
An exoskeleton is essentially a robot that interfaces with the human body.
These can be used in a lab on a treadmill to answer a particular research question, or they can be used outside in nature to help people go for a hike.
The team is currently in the process of testing hip, ankle, and leg exoskeletons.
This ankle exoskeleton, or simply a wearable robot, has a motor at the waist belt, and we have an ankle pulley at the ankle such that the motor can actuate this ankle to lift up the foot when walking and also push you.
With our hip exoskeleton, it's to assist your hip swing while you walk. You've essentially got a belt that sits on your hip, and then you've got motors that are attached to that belt. Those motors will drive one way or another, and then that'll drive the interface, which pulls your leg along.
While the mechanical design may look simple, there's a lot that goes into the engineering process.
So in order to get the exoskeleton to work properly, you have to have an understanding of how the electronics work and how those are connected, and then you have to write code based on how those electronics are connected. Some of those electronics that feed into that brain are the motors. Those motors are going to be telling the brain of the exoskeleton, hey, here's our position, here's how much force we're providing.
One of the things that make these devices unique is their ability to help strengthen muscles.
We pioneered this idea of using a powered exoskeleton, so a powered motorized leg brace, not only to assist people to make walking easier, but also to resist them, and to resist them in such a way where they're training their own muscles to become more effective.
So we can start working our way.
As someone living with cerebral palsy, Ryan Richardson understands the positive impact that these devices can have for people facing mobility issues.
My gait is different, I'll say, and that's one of the reasons why I've really enjoyed coming and testing out these exoskeletons, because it's very noticeable to me between using the exo and then not using the exo, the ease with which I walk or move.
In addition to testing the exos in the lab, the team also spends their time testing the equipment in the real world.
So it's important to do a lot of real-world studies outside in terrain that isn't just a flat floor in the lab, because that's where these devices are actually going to be used, and it's where they're actually going to make a difference in people's lives.
For Zach and his team, the end goal is the same: to help improve the lives of people living with neuromuscular disorders.
I think there's a whole lot of possibility here, and that's why I'm excited to be able to come in and help.
I love actually building or working on research that is geared towards rehabilitation for individuals. Back home, which is West Africa, I've seen several individuals with these impairments end up on the streets begging because they don't have these devices to support them. Walking becomes a challenge, something that you and I can take for granted.
There's millions of people in the world that can benefit from the type of technology that we're working on.